Today we're talking about the multiplying of polynomials. So the product of two polynomials is always going to be another polynomial. Remember, polynomials are things that have multiple terms. So we can use the distributive property to multiply two binomials. So here's the first example. So as we know from previous years, we could do x times x. That gives me x squared. Then x times 5 gives me 5x. Then I could do 2 times x to get 2x. 2 times 5 is 10. Then I look to combine any like terms. I can see x's can go with other x's, and that would give me this trinomial of x squared plus 7x plus 10. So we're multiplying two binomials, and we end up in this case with a trinomial. So again, for the second one, x times x is x squared. X times negative 4 is negative x squared. I'm sorry, negative x plus 3x minus 12. So just using the distributive property. And again, I see x's in common. So x squared minus x minus 12. So then we can use this thing called a table. It's not one that you probably would use the most, but it is another way that you might see this as a way to organize. So if I was to do this, I would just kind of write it and kind of form this little box or a table. And basically what you're doing in here is that you are going to be multiplying. So 2x times the x will give you 2x squared. And then I would do 2x times the 5 now to get 10x. And then I would go down to the next row and I would do negative 3 times the x to get negative 3x. And then the negative 3 times the 5 to get the negative 15. And I still have to combine my like terms. There is no other x squareds, but there are some 10 and negative 3 x's. And then I would have the negative 15 to be minus 15 at the end. So that's another way of looking at those if you would like to look at a box or table method. So then we use this thing called FOIL. It's a shortcut. It's really very similar to the distributive property, but what we're doing here is, if you see the example played out, you see FOIL stands for first terms. So I would multiply the first terms, the outer terms. So instead of going x, it's really another distributive property. Then I would do my inner terms, and then I do the last terms. So just about the same thing as the distributive property, but FOIL will sometimes help you remember to hit all of them. Okay, so we're going to use the FOIL method to do these next couple of examples. So the FOIL method for this first one here would be first terms gives me x squared. Outside terms, negative 6x. Inside terms, negative 3x. And then last terms plus 18. Again, we always combine our like terms. And there it is. And on the next one, our first terms. Now I get 6x squared. Then I get my last terms, negative 10x, my inner, and my last. Again, I can combine some x's there. So 6x squared minus 7x minus 5. Always make sure you're hitting those inner terms. These two binomials are right now all giving me trinomials. So then we want to multiply this binomial times a trinomial. So this is where it's really important to think about the arrows. How are you organizing your work? So first, x times x squared. That gives me x cubed. There's 3 of them. Remember our power rules. Then I get negative 3x squared. Lastly, I would get negative 2x. Then I can move on to the 5. I'm going to get 5x squared. I'm going to get negative 15. Negative 15x. And then the last part is negative 10. And it's important to make sure you hit all of them. Now it's important to make sure I combine everything. Well, I don't see any other x cubes. I do see x squareds here and here. Negative 3x squared and a 5x squared is 2x squared. I also see x's. Negative 2x and a negative 15x is negative 17x. And then I have this last 10 here. There would be my answer. Combined, multiplied a binomial with a trinomial. Now lastly, we want to look at this. The goalie area behind the goal line is a trapezoidal region. So we first want to write here a polynomial that represents the area of the trapezoid region. So if you remember from the past, the area of a trapezoid equals 1/2 base 1 plus base 2 times the height. Remember, there are 2 bases in the trapezoid. That's the parallel lines that are the bases. So looking at our picture here, we have a couple of things we got to look at. So first, the 2 parallel lines. These 2 right here are our bases. The height is always the perpendicular line between the bases. So then, if I just start plugging in my info, base 1, and then base 2 would be the bigger one at the bottom, and then the height would be x minus 7. So using what we learned in a previous lesson, we first want to just add together to get 2x plus 10 for the inside. To get to that. Now you can do this a couple of ways. I'm actually going to do this times 1/2 first. So I'm going to multiply 1/2 times 2x to get x. And then I'm going to do 1/2 times 10 to get 5. And that'll kind of make this a little bit easier to look at. So then let's just keep coming down here a little bit. So now when I multiply together, I get first x squared, outsides negative 7x, insides 5x, and last 35, or negative 35. So our polynomial to answer the first question is x squared minus 2x minus 35. Here's the answer to A. Now, B says, find the area of the trapezoidal region when the shorter base is 18 feet. Well, what is the shorter base? Shorter base is right here, right? Because x plus 10 has to be bigger than that one. So we now know that is 18 feet. So we can definitely use our polynomial to help solve this. You could go back and use the 18 feet to plug it back into all the information. But if we wanted to use the polynomial, you would just plug it in and then you would get your answer. So if I plug this in, squared is going to give me 324. 2 times 18 is 36, minus 35. And the total there is an area, probably should have this all the way across, huh? The area is 253 square feet. So that is multiplying polynomials. We'll be doing a lot of this, and very shortly we're going to be kind of doing some other work that's working backwards to get to this. So I hope this made some sense. Hopefully you do well with it. If you have any kind of questions, please feel free to ask me the next time I see you in class.